In the circuit shown below, the AC source has a voltage V is equal to 20 cos omega t volts with omega is equal to 2000 radians per second. The amplitude of the current will be nearest to which of the following options? We can assume that current flows with the same frequency as the voltage does, which means I is equal to I naught into sine of omega t plus phi. Why did I put a plus phi over here? This would be some phase difference, just to denote that current has the same angular frequency but it has a different phase. Now what is the potential difference across a resistor in this condition? The potential difference across a resistor would be equal to Ri, which is R I naught sine of omega t plus phi. The potential difference across an inductor would be L di by dt, that is L I naught omega cos of omega t plus phi. The potential difference across a capacitor would be Q divided by C, but Q is the integral of the current, so we have I naught by C omega into minus cos omega t plus phi. The integral also gives us a constant of integration, but we can ignore that and assume that the current has a mean value of 0. So in our circuit, what is the total resistance? We have R is equal to 6 ohms at the resistor and 4 ohms at the inductor. Therefore, the total resistance is 10 ohms. The total inductance is 5 millihenry and the total capacitance is 50 microfarads. So now what is the total potential difference across the entire circuit? V would be equal to 10 I naught sine of omega t plus phi plus 5 into 10 to the power minus 3 into omega minus 1 by 50 into 10 to the power minus 6 into omega into I naught cos of omega t plus phi. So let us find out what these coefficients are. We have I naught multiplied by 10 sine omega t plus phi plus 5 into 10 to the power minus 3 into 2000 would be equal to 10 minus we have 1 by 50 into 10 to the power minus 6 into 2 into 10 to the power 3 cos of omega t plus phi. And this part in the denominator becomes, we have 10 sine omega t in the first line plus 10 minus 1 divided by 0.1 into cos of omega t plus phi. Now we can see that 10 minus 1 by 0.1 would be equal to 0, and therefore the total current would only be this part I naught into 10 sine omega t plus phi. Now we need to say that I naught into 10 sine omega t plus phi is equal to 20 cos of omega t. What is the maximum value on both sides? We have 10 I naught is equal to 20 or I naught is equal to 2, and hence option A is the answer.